slides. And just a disclaimer, as much as I'm going to cover a lot of the skills you need to be versed with as a data scientist, I might leave out a thing or two, a couple of things as well. If I do leave out a couple of things, just check out the email. That should have a more detailed breakdown. But I think I scoped through data science pretty well on this call, at least for those who want to start off their careers in the space. Okay, so let's get started. I hope you can now see my screen. Okay, if you can see my screen, just confirm it to me, and then we can get started. Okay, there we go. Think I'm all over the place, and then we can get started over here. Awesome. Yes, you guys can see my screen. So let's get started. So today we're going to talk about the data science roadmap. In this call, we won't get deep into data science. We won't get anywhere close to the technical skills. It will just be understanding the roadmap you need to follow if you want to learn data science as well. I will start with why learn data science and what is data science in the first place. So that will be a good starting point for us. Okay, so let me just go ahead and present and we should be good. So before we even talk about what data science is, the big question people usually have is, why should I be learning it in the first place? What are the expected opportunities in the space? So usually I always try to review this by looking at the job industry to see what roles people who've learned data science tend to get. With skills in data science, you could opt to be a data analyst. So most of the time you'll be posted to a company and you mostly work under the business intelligence team. Not usually, if you're working in software development, every product team will tend to have a data scientist or a data analyst. Yes, once again, in the world today, we always need to use data to inform our decisions, and that's what data analysts do. You collect data, right, to understand whether your company needs to do thing X or not. So if I'm a software development, I will create a feature. I will measure how people are using it, right? I define the different metrics that I'll be measuring. And at the end of the day, based on the sort of success metrics you wanted to hit, you could go ahead and ask yourself, was that feature a success or not? So a good example is by Google adding the calendar, you know, the sidebar they have on the right of your Gmail right now. You can go ahead and measure. What would you measure to see whether that feature was a success to Google as a company in the first place? So those are some of the challenges we see, whether it's software dev or whether you're working for any other department. Data is very, very important in informing our decisions. Cool. The second role we see here will tend to be data scientists. Now, data scientists go a notch deeper from just doing data analysis. They tend to also make predictions. So let's face it, if I'm a data analyst in the finance world, I could easily analyze a company to understand its revenues, right? You want to understand what stores are doing better, right? Where we should invest more as well. So you're collecting data, you're analyzing, you're getting insights, it's informing your decisions. However, if I was in the same space as a data scientist, then all of a sudden I can go a notch deeper by trying to work on projections now. So how can I predict future revenues, or now start modeling out things if I was to open a shop in this new location? Based on the metrics I've seen from my previous shops, how can I predict the expected revenues off of that? So this one now takes you off from just doing simple analysis to now being involved in making proper predictions, right? Having that, now you're not just generating insights based off of data, but rather you're even making predictions and expectations using data as well. So that's usually the layer of data science over here. And it involves a lot of machine learning. However, some of you guys might end up opting to be data engineers. Now, what is data engineering? Data engineering will tend to be people who skill themselves to work with the data pipeline. So how do we collect the data? How do we clean that data so that we can serve it to our machine learning algorithms? So once again, data scientists are using machine learning skills to be able to make predictions. Very, very key aspect. But for you to make predictions with machine learning, you need a lot of data. So data engineers will now come to our stack to now structure out how we collect that data, how we clean it so that it's good enough for our models, and then how we serve it to these machine learning models. So a good example here would be a data engineer. Let's say I was a data engineer at YouTube. My team would be concerned about how we collect viewership data from YouTube. So let's imagine we have HB going on a YouTube channel, viewing a video, and she only views it for 2 minutes, right? That's a data point that I'm collecting. Probably that data point is important in predicting whether we should recommend a video similar to this in the future. So because she watched it for less than 10 seconds, probably we shouldn't recommend a video that's similar to this in the future. So now data engineers will collect that data, they'll clean it in a way or two, right? Probably you watch it for 2 seconds, but my machine learning algorithm is only asking questions of whether it was you watch it for 10 seconds or more, or we've categorized rather than just give it a numerical value. So based on how your machine learning algorithms need to take in the data, you probably clean that as a data engineer as well. And finally, you feed it to those algorithms before they can make a new prediction again. And when it comes to making predictions, we'll see the AI and machine learning engineers will be the ones working behind these machine learning algorithms to design models that will be able to make predictions for us or do classification, whatever that is. Okay, so this is just a general overview. I'm just trying to walk through it with very, very simple examples. I think for the next call, probably I should give you guys a sample example of a task that someone needs to fulfill in the workplace and where each and every single one of these roles would play. However, of late, not actually of late, I think we've heard of quant analysts for a while now. This is also more of a data science field, but mostly in the financial world. Most quants would tend to be quite vast with some of the skills you have in data science as well. Okay, so that's just an overview of the stack and different roles you can be. This is not exhaustive. Usually some companies these days also hiring business intelligence experts who have a base in data science as well. Okay, so one thing we should note is when I'm explaining this, you see me leaning towards explaining it from a business perspective. So how can you make more revenues? Because that's usually the business of business, right? Or from a software development perspective, in that how well is my application performing? And I'm just doing that because I have a personal bias because of my software development background. However, the skills you're talking about in data science could be applied across numerous other industries. It depends on your domain. So whether you're into biochemistry, you could use data science skills for medical research. One interesting thing about data science is we've seen machine learning algorithms being able to predict death of critical patients with up to 97% accuracy. So think about medical research. If you're able to make that prediction with ML quite early on, it does help doctors know what to do and how to allocate resources within a hospital. Another thing we're seeing is detecting cancers quite early is something we're seeing machine learning being used for in medical research. So there's a lot of applications over here when it comes down to data science. Sports analysis is also a very interesting thing. I'm personally a football fan. For those of you who are Americans, let's call it soccer. And at times you want to know the potential of a player from a very, very young age when they actually chip. Think about the amount of money that goes into investing on high caliber players. So most of people in the sports world have now come up with ML algorithms that can track movement of players. And these days, teenagers play with wristbands so that they can collect that data. And when they analyze this data, scouts can easily now start identifying players who are likely to have high valuation in the future or play in certain positions as well as they want them to. One that's very, very common these days, driverless cars. If you're following the Tesla, Waymo, or even Aurora, it's a huge competition over here. That's more AI as well, but it still stems from data science as a starting point as well. Think about fraud detection. If you end up working in finance, right, compliance, fraud is a big thing in any financial industry, whether you're working in insurance or banking. Right now, we don't need to go the extra mile with a lot of documents. People can easily analyze transactions to detect possible fraud. Finally, this has really helped the insurance industry. Business intelligence, I've talked a lot about this. The best way to get insights from data in companies so that you know what to do. Business intelligence is a core aspect of pretty much any major organization these days. And let me not just talk about business intelligence from that where should our business go next, but even from our product, like what products, like what features should we add next to our product. People are using data science a lot in determining what how they should transform, or what sort of additions or modifications they should make to their business or their product to make it better for the end user. Governmental planning is also a very, very good task to use data science for. So that it could be either predicting population growth, right? It could be modeling out how, like, government finances as well. So there's a lot that could go down on governmental planning. Once again, I'm not so vast in that to talk so much about how it's being used over there, but governments also want to detect fraud. Think about revenue authorities, an organization like the IRS. So there's a lot of departments in the government, or rather parastatals, that could easily work with data science. Finally, we've talked about quants over here. You can also think of data science whenever you're doing your trading or valuations. But even if you don't want to work across any of these industries, you can use it for fun. So for instance, I'm not a sports analyst, but one interesting project that I was able to work on because of data science here has been playing fantasy football with by creating machine learning algorithms that predict which player is likely to score more points on the next game week, for those of you who are into sports like that. So you can also use it for fun. There's a lot to do. We're seeing people trying to use data science to be able to mix music. So think about you have a playlist, you want to blend in music as if you're a DJ as well. Yes, we have DJs, but we're seeing people starting to use machine learning to be able to create their own mixes based on their own taste as well. So there's a lot you could do with this. It's still a new field, and data is powerful. That's the core of our discussion today. Okay, so just from my overview here of why we should learn data science, you guys already start to see an overview of what data science involves. So one, data science will involve a lot of data analysis. So how can we get insights from data? That's a core aspect of data science. Second layer of data science would be that machine learning layer, which is how can we now use data that we've collected before to make predictions, right? Very, very key aspect of data science as well. And then we get to the final layer of data science, which means that we can start automating some of the tasks, right, that were quite trivial for typical software developers, just by teaching machines to learn from data. Think about a task like driving a car. If we were to create code that allows you to drive a car, that's almost impossible. Are you going to code up all the different types of pavements that we see? Are you going to code up all the different sort of expectations you have of different vehicles, or how drivers can swerve in? You really can't hard code each and every one of these things. But what we can do now is we can feed a lot of data to machines, and all of a sudden they can learn and they can expect the situations. And that's why we're even using it for driverless cars, or we're using it for trading as well. That's the power of data. We don't have to hard code the hard things anymore if machines can create their own systems of learning this just by learning from past data. Okay, now up to there, does anyone have a question for me, given that I've talked about why learn data science and just in brief what data science is? Okay, any questions? If you do have a question, you can drop it on the chat. What team do I support? That's a very, very interesting one. For those of you who are English, I am an Arsenal fan. It is sad it's not something we say in public anymore. But yeah, just give it 3 more years and probably we might be contesting for titles again. Yes. Thanks for that question. At least it makes the conversation slightly lighter than what we have over here. Okay, now it seems like my image is not loading, and I expected this as well. But I want us to talk about the data science Venn diagram. Because I can't find a way to load this image, I'm just going to look at a typical data science Venn diagram online. Let's see what they have here. Cool. Can I make it larger? Okay, this is about it. I thought you could make it larger. Let's see. Let's see. I think I clicked the wrong button. Okay, so let's talk about the data science Venn diagram, and this will tend to be what we call the pillars of data science. Why the data science Venn diagram is misleading. That's a very, very bad way to get that image from. Let me look for Let me look for a Venn diagram that is very, very close to what we were using. I think this should be it. Okay, so I hope you guys can see the right of my screen, even if it's a bit small. Once again, my image cannot load, but I'll go ahead and use this Venn diagram. They're pretty similar anyway. Okay, so let's talk about the Venn diagram. So we usually talk of data science as three particular pillars. So the first pillar will be your hacking skills. Actually, let me talk about math and statistics as your first pillar. This is a better diagram. I think this is a better diagram. So the first pillar of data science will tend to be mathematics and statistics. At the end of the day, for you to get insights from data, just in the past, we've been using traditional statistical methods to make these insights. And these are still the same principles we apply when you talk about data science. So for you to get into data science, you need to have a very, very good background in math and statistics. And I'll talk about some of the mathematical topics and statistical topics we need to talk about. We use the math to design and optimize the algorithms we use for machine learning models. I'll talk about that as well. It's the statistical concepts that define how these models work in the first place. So understanding statistics makes you understand when to choose a model, why this model is ideal for that particular problem, and how you can tune that model for higher accuracy as well. So learning math and statistics is a very, very core skill for any data scientist out there. The second aspect of data science, or rather key pillar, will be computer science. Other Venn diagrams will call this hacking skills like the previous one. Others will just call it programming. In data science now, we're not using your SPSS or your Stata or your Stata tools or your typical data tools. Yes, you can still use Excel for data science. I'm not discounting that. But because we want to be able to customize how we do statistical analysis on a computer for speed, right, and efficiency as well, and to be able to feed in these algorithms that we've optimized, and knowing how to program is very, very key, because we won't just be working on a typical Excel sheet, but we will be working with a programming language to do the statistics or rather predictions that we want to do. So learning how to program is an essential skill for any data scientist, and we will talk about some of the recommended programming languages over here. Python is definitely the leader when it comes down to that. Now, when you do combine your knowledge in math and stats and computer science, what you end up with is machine learning. So that's what we get from that. People who are very, very vast in math, statistics, and computer science are well okay to get into the machine learning field very, very well. But data science needs you to be a domain expert to be able to harness the full power of what the career is. So it does not matter how much statistics or computer science you know. The question is, for this given task, do you have enough domain expertise to understand what this data means, what the different features of data means, and how people navigate data in this particular field? For instance, if you're not into sports, if you're not entirely into sports, you would not know why people measure indexes such as XG. What does it mean in the first place? Yes, you can play around with the data, you can feed it to a machine learning algorithm, but understanding what that does comes from your domain expertise in that particular sport in the first place. So if you're a doctor as well, right? If I'm a doctor, and I've been a medical doctor for 15 years. Probably I work with cancer patients as well. I work behind the X-ray. I already know how I can look at an X-ray image to detect cancer, for instance. So that's like a task you want to, if that's a task you want to achieve with data science, then having a doctor who already knows how these X-ray images look like in the first place, or what to look for, or what places we should be scanning in patients to see whether they have early stage cancer or not, that domain expertise is relevant, whereas you could get the best data scientists in the world, but if they don't have that medical experience, or they don't team up with someone with that medical experience, all of a sudden that's useless. You could be the best data scientist in the world, but you can't do financial predictions unless you do have some expertise in the finance industry a bit, or you team up with people who are vast in that. So domain expertise is a very, very core thing. Now, when you combine domain expertise with computer science, that will tend to get your typical software development tasks, where we use our programming skills to create tools that we use for different domains. So if I'm a marketer, right, and I understand computer science, I could go ahead and build a tool such as MailChimp that allows you to send automated emails. However, we usually call that the danger zone, because no matter how good a computer scientist you are or a domain expert you are, at the end of the day, you still need to measure out data to see how useful whatever you're building is to the end market. So it is a danger zone because it cannot exist by itself in the current world, as you see. If you do just combine domain expertise and statistics, you can end up doing traditional research. That's what we see a lot in universities, where people know a lot of statistics and they're studying a particular domain, and they tend to do research, right, on how they can make advancements over there. So that's okay. So applied stats and domain expertise, traditional research. Applied stats and computer science, we get machine learning. Computer science and domain expertise, you get that sort of product software development as well, so building software, but I will call that the danger zone. And when you combine the three of them, we get that sweet spot that we call data science. Cool. Any questions for me so far? Any questions? I will get to the chat again. So is R a good place to start? Cool. Good question. Let's get to that question now. Okay, so let's talk about where getting started as a data scientist. So before we even talk about the programming language, the first thing you guys need to be familiar with and you need to get set up on is where you will be working on that programming language in the first place. So because you have to learn programming, it's very, very essential that you have what you call an integrated development environment on your computer. I will term it as an IDE for this call as well. So it's good to have a local IDE on your computer, and this allows you to program and practice out your code. This is how people build code using an IDE, the software for writing code as well, right? So the popular one here will be Visual Studio Code. Sublime Text comes close as well. You'll have Atom as an option. If you don't want to work on it on your local computer, we have online versions such as Replit or GitHub Codespaces, which interestingly is just Visual Studio Code online. So those are some of the core tools that you should be able to have. I recommend having Visual Studio Code because it's a perfect IDE for any programming language you're learning. I think it's the most popular one out there. But you'll see why I still recommend Visual Studio Code with my next thing. So for people who are into data science, it's not just about you using your typical IDEs. It's you using your typical IDEs, but in particular, being able to use what we call IPython notebooks. So an IPython notebook is a special development environment that allows you to view data as you're coding. So it's not like your typical programming file where you run everything on the terminal. This one, like, you run per cell, you view the output. So it makes your data science code come off as if you're building a document, which is the interesting thing about it. I wish I could show you this on GitHub. So I could just jump here, click on GitHub here. Let's see what we have, and we'll see what's the difference between a typical code file and a machine learning code file. So a second example of what this looks like. Boston Advanced Regression. This is a very, very poor code, so not really as structured as you want it to be. So your typical development environment will just have the code, right? And you have to run things on the terminal, but you'll see how differently this looks when you're working on an IPython notebook. You run things per cell, you're able to visualize your data as well on that development environment. And that's what I recommend for your data science tasks. So when you're learning programming, use your typical local IDE, understand how people program typically over there. But when you start getting to data analysis, I do recommend using an IPython notebook. So for some reason, I can't load this, which is quite sad. Let's hope this is going to work now. Okay, there we go. So think about this now as your typical code file would not come off like this. So if you're working on a typical IDE, but when I use an IPython notebook, I can source data and visualize the data in a table over there as if I'm working on Excel. I can describe the data and get my mean and visualize it there as well. And it's this like document-based approach to programming that's quite interesting and very, very useful for data scientists. So here I was looking for, is there any missing data in that particular file, in that particular data set? And I just decided to visualize it, and the white spaces were the missing data. And this makes it very, very easy for you to work through data because you're programming in a cell and you can visualize your output like that. Partly because you're working with data, you want to see your visualizations, you want to see your tables, you want to see your summaries as you're working on that particular code. So what are some of the common IPython notebooks? This is a Jupyter notebook, right? This is a Jupyter notebook. It is your typical Jupyter notebook. So go ahead and download the Anaconda environment so that you can access Jupyter notebooks. Another option here will be Google Colab as well. This is the online version of Jupyter notebooks offered by Google. It saves your documents straight up to your Google Drive. Very, very helpful for a lot. And the good thing is it integrates with GitHub quite easily. You will see that. Actually, everything integrates with GitHub quite easily over here. And the final one here is you could still opt to use VS Code by just installing the Python extension. And whenever you're starting off a file, all you have to do is just name the file with this extension as its ending, and it's going to become a notebook. So that's why I recommended Visual Studio Code in the first place. You can use it for your typical programming, but by installing this Python extension and just calling our files with a .ipynb extension at the end, you're able to create IPython notebooks from Visual Studio Code still. So you're able to get a Jupyter notebook on Visual Studio Code without downloading an additional tool. Okay, second skill that's very, very essential for any developer regardless. Once again, we've talked about hacking skills being very, very important. And because you guys are hacking and you guys are programming, all programmers need to be familiar with Git. You need to be familiar with how you work with Git Bash. Right, you can go ahead and search what Git is and what Git Version Control is. This allows us to view how our code changes over time, particularly when you're collaborating with a lot of people. You guys are pushing changes to a particular repository individually, and all of you should be able to track how these changes are being made, when they were made, when issues arise in your code, and you can be able to track what changes were added before this issue arose in the first place. So Git is a very, very essential tool for developer collaboration and controlling the versions, as in what changes have gone to my code base over time. And the good thing about some of the Git solutions we work with over here, they allow you to host your code online as well. So it's quite easy. Instead of me opening up a file on my laptop, I know I can go to my GitHub account and just look at some of the IPython notebooks I created for this house price prediction task that I was doing a while back as well. So there's that. Some Git solutions you can use, right? Once you learn Git Bash, for data scientists, you can also just work with GitHub Desktop, which means it makes it easier because you don't have to learn this Git Bash commands as well. So if you're working with GitHub Desktop will work well for you. Other enterprise solutions will tend to be GitLab or Bitbucket. Depending on what company you end up with, you'll tend to use one of the following tools. These are the market leaders over there. I recommend GitHub. They have a good free version. It helps you get started as much. And there's also a lot of open source repositories that you can learn from as well. Cool. Now let's get to the third aspect for you to get started, and that's definitely the hacking skills, right? Learn programming. So these are my 3 recommended languages for anyone who's doing data science. You can either learn Python, Scala, or R. So I was asked, is R a good place to start? Yes, it is. R is a good place to start. R is a very, very statistical language. You will see that it's very, very good for data analysis. It's one of the top 2 languages when it comes down to data science. However, my main recommendation here, my personal preference here will tend to be Python. And it's because by working with Python, you're able to work through a lot of things across the data science task and even model deployment if you ever want to work with these libraries that allow you to deploy your models online as well. So Python has additional utility in software development, which really, really helps you. It has additional utility in data engineering as well, which helps you, whereas R might be slightly limited because it's mostly focused on statistical aspects. It's going to do your algorithms and machine learning pretty well as analysis, but you'll see Python has a wider scope in case you want to expand your knowledge into other aspects such as, yes, software development and the likes. I definitely recommend Python. It is the popular one at the moment in the market. So if you decide to learn Python, what are some of the key topics you need to learn? Of course, start with the basics. What are variables? How can you write down expressions here? Can you work with Python loops, right? Go through how to design Python functions or the Lambda functions, how to work through with conditionals. Those are some of the basic things in Python. Should take you about a week for the basics or less. Then start learning about data types, right? And the different methods around all these big data types. So you have a lot of different data types here: strings, dictionaries, files, lists, tuples. I've just mentioned a few of them. But now, for any Python course, you'll do the basics, you'll do the data types. There's no avoiding that. What are some of these skills that you should learn most definitely as a Python programmer, particularly if you want to get to the data science track? You should definitely learn some of the web skills I've listed here. So regular expressions, very, very essential for cleaning data, particularly when you're web scraping. So make sure you learn how to work with regular expressions on Python. Second skill is learning how to scrape data. At times, you won't have data served to you in a CSV file, right, or an SQL database, and you have to go to a particular website and scrape data off of it, right, using your programming language over there. So learning a library such as Beautiful Soup, right, request allows you to be able to source data from any site over there. Good example is if I wanted to just collect data on products, right? Their prices, and let's say how many people have bought it on eBay. I could just scrape that data if eBay does not allow me to access their database through an API. So scraping does really, really help you with data sourcing. Final aspect is APIs. Learn how to work with APIs. A lot of companies have public APIs that allow you to access the data within the databases. Think about if I want to see statistics on YouTube videos, I could use the YouTube API. Very, very essential thing there. If I want to get, let's say, the prices of cryptocurrencies for the past 10 years, if that's an analysis I want to do so that I can make my crypto price prediction, I could just go ahead and look for the CoinMarketCap API, and I already have a window to that entire database just by designing a program to source data from that API. So learning how to work with APIs, very, very key skill. On the advanced side, any programmer should learn object-oriented programming. It's the standard. Learn object-oriented programming, very, very essential with Python. And then go ahead and learn some of the Python conventions. Yeah, so how do you work with Python modules? How do you work with Python packages as well? What are the proper conventions for writing proper Python code? Can you do testing with Python as well? So those are some of the additional skills we're talking about there. Additional skills we're talking about there. Any question for me before we get to data analysis now? I'll go ahead and look at the chart now. Adria, I hope I've answered your question in terms of whether R is a good place to start. It is a good place to start. Just Python is more popular. Python has more utility. You have more opportunity by going through a Python track than R. But you will see that R is very, very common for data analysts, and it's also very, very common for those of you who are in a university research setup. Okay, so second phase of your data science roadmap would be learning data analysis, how to analyze data. And there's different ways to analyze data here. One, we can analyze data using Python. You can analyze data using a data tool, or you could analyze data straight up from an SQL database using SQL. Okay. The first one that I'm going to talk about here is Python data analysis. Here I'll just list some of the libraries that you should learn if you want to know how to play around with data analysis on Python. NumPy is the library that allows you to work with arrays. The problem with Python is data is usually structured in lists, but whenever we want our operations to be faster and more efficient, we want them to be vectorized. For those of you who are mathematicians, then working with arrays is way better, and NumPy is that library that allows us to do mathematical operations with arrays. Yes, so it's called, is it numerical Python? So that's it, NumPy. The second one is Pandas. Now, Pandas is what allows us to have tabular data on Python. A good example here is you guys can see a table. It makes Python an Excel sheet. That's what I would call Pandas over here. Allows you to do data analysis, data manipulation on your data as well. Pandas is the library that allows you to navigate tabular data within the Python environment. Final thing you want to learn is data visualization. And here there's tons of libraries that you could learn here. The one I recommend is learn Matplotlib. That's the most basic library you can learn for your visualization tasks. It has a lot of utility. You can expand your visualization techniques by learning Seaborn. Seaborn has some plots that are not available on Matplotlib. Or you could go an extra mile by learning Plotly and Bokeh. Those are some other ones. By knowing Matplotlib and Seaborn, you're really, really good to go. In fact, by just knowing Matplotlib, you're really, really good. Seaborn just allows you to do additional plots such as heat maps, right? Or things such as this. This is a missing value heat map that's not available in Matplotlib, but Seaborn allows me to do that. But all your typical plots, think about a box plot, a bar plot, a line, a scatter plot, right, are available on Matplotlib. Pandas also has an extension called GeoPandas that allows you to even plot graphical data. So that's also a skill you want to learn as you're doing your data analysis. Not graphical data, I'm talking about map data. Because at times, data does come in maps. Think about COVID cases last year. All data sets, or rather all visualizations, used to have a map of how many cases across different countries. You could color different countries differently based on the number of reported COVID cases as well. So knowing how to work with map data visualization is also a very, very important skill. Okay, now second layer of data analysis is learning how to work with databases. When you're learning how to work with databases, we'll want to learn how to source data from these databases. When you're learning pandas, you'll tend to know, you learn how to source data from an Excel sheet, from a CSV, from a JSON file. So pandas does give you an edge over there so that you don't have to learn a lot of things. But what we still have a gap on is a lot of the data we see in different businesses today is still stored in SQL databases. So it's good that you learn how to work with relational databases. Good examples include MySQL. Postgres is also a very, very common database. I care less about what SQL database you use, but more about, are you familiar with SQL queries? Do you understand database structures around this? Can you structure out queries that allows you to analyze data from the database straight using SQL as well? So SQL programming is a core skill. On top of that, make sure you know how to source, or rather connect to NoSQL databases. So CSV, that you can do with pandas, but Python has a special library called JSON that allows you to work through JSON files, because a lot of data that's not in an SQL database will tend to be stored in a NoSQL database such as Mongo, that the format will be in JSON. So knowing how to navigate JSON files is very, very essential. Whereas navigating a CSV file is quite easy. That's what an Excel sheet could be, a CSV. And the same way you see it in an Excel sheet is the same way it's going to come on pandas. Some additional tools you should be familiar with as a data analyst, right? With your data analysis here is, it's sad to see any data analyst, right, who's not familiar with Microsoft Excel. This is a very dominant tool across the industry. Regardless of how much programming you use, there'll always be some things you want to do very, very simply on a Microsoft Excel sheet. There's always some things that you don't want to overcomplicate, because everyone in the team needs to be able to understand it and manipulate it as well. So working on Microsoft Excel, and not just your basic Excel, but rather advanced Excel, is a very key skill for any data analyst or data scientist in this case. Tableau is a very common and popular tool for data visualization. Companies are using this tool a lot to make their visualization easy. It connects straight up with an Microsoft Excel as well, so that you can make proper visualizations. Tableau is a Salesforce tool, so there's a lot of utility around it today. Very, very popular. Learn Tableau. In fact, you guys can work in data analysis by just learning Excel and Tableau, so long as you have the domain expertise of that industry you're going to. And Python would just be an added benefit. But you could also be very, very good with Python, but there's the skills you don't want to be left out on, because some companies will force you to use some of these tools. Once you know Tableau or Microsoft Excel, upskilling into tools such as Power BI will just be, oh, company X decided to switch from Tableau to Power BI. How can I go through a 1-week course to learn how Power BI works? And once I start using it, you'll be able to learn it. So learning one tool makes it easy for you to learn the other tool. Just make sure you know either Tableau, Power BI, but definitely know Microsoft Excel. Okay, any questions for me there? Any questions? I will check the chat again for a question. No question this time round. Now let's go to the next step now. Let's now get to the core part of data science. So you're now a data analyst. You can go out there and source data analyst jobs. In fact, the skills I've talked about are skills that are covered on two particular Coursera courses. We have the IBM data analysis course and the Google data analysis course. The only difference is the IBM one uses R and the Google one uses Python, but they'll tend to cover all the skills I've talked about right now, and all of them will give you a data analysis certification, and they already have partnerships with companies that are willing to employ you as soon as you have those skills and you have that particular certificate. So yes, based on what certificate you have or your background here, you can start getting data analyst jobs with some of the skills I've talked about already. But I would recommend going an extra notch if you really want to get into data science. So let's talk about data science core. In the beginning of the call, I talked about math and statistics being a very, very important feature, or rather pillar, for data science. So what are some of these mathematical topics and statistical topics you should be familiar with? The first mathematical topic you should be well versed with is linear algebra, right? Our machine learning algorithms are based on algebra. We're doing linear programming to be able to optimize our models over here. So having a good understanding of vectors, matrices, right, and the concepts around that, very, very essential. Second thing that we use to optimize our models, because once again, when you're coding in a model, when you're building an algorithm, a machine learning algorithm from scratch, right, you're using mathematical principles so that you know how this algorithm should work through the data. Most of you, it's always just nice to get the concepts, because with the libraries we have, you'll tend to be out of touch with the math unless you're working in advanced machine learning roles where you really need to be familiar with that. So knowing the concept is more important than knowing how to calculate all these things from scratch. So there's that. So linear algebra, key thing, learn about vectors, learn about matrices, learn about linear programming as well. So how you can play with vectors and matrices with Python or R, whichever programming language you choose. Second aspect here is multivariate calculus. So we'll still be using calculus with linear algebra. That's what allows us now to solve problems as well. This is where now we can start optimizing our algorithms. Calculus makes everything easier, right? So some hard problems that we could solve, you can easily start estimating the moment you start learning calculus. So concepts such as Taylor series or things of that sort. So I'm not going to talk deeply about this. I will recommend a course by Imperial College London that talks about these two concepts pretty well, and I recommend anyone just to go through those ones. They're very, very short videos, about 24 each, that upskill you into linear algebra, just remind you some of the skills you learn in college without really forcing you to get down and on a pencil and paper and do the math, so that you just get an understanding. Second layer is when you're working with data science and machine learning, the core concept we're using here is statistics. We're using statistical concepts. So being familiar with inferential statistics and probabilistic statistics will give you an edge in understanding what different models do and how you should be using them, because at the end of the day, they're all based on stats. So learn probability and statistics, learn inferential and descriptive statistics. Descriptive is easy, that's grade 6 work, mean, mode, and the likes. But inferential is what you want to focus your time on. And then with probabilistic statistics, you want to learn about probability. Think about combinations, permutations, topics such as Bayes' theorem as well. I will give you guys a listing of a good resource. Khan Academy is definitely a good place to learn all this all at once. The final one, I'll leave it as red for now, because it's going to be people in deep learning who tend to learn convex optimization to a very, very deep level as well. It's still a combination of that math, right? And this will tend to be this will be more of the hard optimizations that we still apply in machine learning algorithms that people who have done advanced calculus, advanced linear algebra should definitely be taking as well. So if you think you're very, very confident with these so far, it's always nice to go ahead and give convex optimization a look. I would just say not all, you really don't have to learn it necessarily, but if you want to get into deep learning and you want to become a machine learning AI engineer, I recommend it. Stanford has a very, very good course on convex optimization. If you have a good mathematical background, that should really, really help you. Okay, now we've understood our math and statistics, or if we've not understood so much, we've reminded ourselves of what vectors are, the concepts behind vectors, matrices. We've sharpened up our statistical knowledge as well. Now we can get to machine learning. So what are the key machine learning problems you should be learning over here? The first type of machine learning problems will be supervised learning. So supervised learning problems where we show the computer data and the solutions, right? And once we allow the computer to learn from data that has the solution, now we can give the computer data and it can make a prediction. So a good example is, let's say I wanted to predict the age of someone, the grade of someone given what year they were born in. So if someone was born in August, right, 2005, what grade would they be? This is a very, very simple task that we can do with our head. I don't know, different countries would be. So let's say typically some countries would be, this person is now in grade 9 or probably grade 10, right? Good example. So someone who's born in August 2005 is in grade 10. Someone who's born in April 2005 will be in grade 10. Someone who's born in, let's say, January 2005 might probably be in grade 9. We're not really sure. It might be 9 or 10 as well. And what you're doing is, if we had a data set with birth dates of different types of children and what grade they're in, and I had 1,000 different rows to this, I could serve it to my machine learning model, right? And it's going to learn from that. And next time I come up with a birth date, like let's say June 1997, it could easily predict what grade that person is, or whether they've already graduated, or whether they're in college, or what year they should be in as well. And it's because it was able to learn from the initial data, where this is the feature and this is the label, so grade 10. And because it's gone through all the features and all the labels, now when I give it a feature alone, it's able to output a label because it's learned from the data before. So those are your typical supervised learning algorithms. So you give your data with a solution. So this will be your X variables with the Y variables, so that next time you only have the X variable, the computer can give it, can output a solution. So some common supervised learning algorithms will tend to be regression algorithms, right? Think about linear regression, polynomial regression. You could think about classification as well, right? If a leaf is of this length, this broad, and this thick, then it's likely to be from this plant. And we can have data on different types of leaves, and we attribute it to plants. And we can allow our computer to learn, so that next time we only have data on the leaf and you don't know what plant it is, our computer can give us that prediction. A good example of a good supervised learning task is spam email. We could go ahead and label different emails as spam or not spam. And after labeling 10,000, a million emails, we can serve it to our machine learning model. And next time someone sends you an email, even before looking at it, you can let your machine learning algorithm tell you whether that's going to be spam or not, because it already trained from previous data that was already labeled. Okay, so regression and classification problems tend to be the key problems for supervised learning. Now, in supervised learning, this will tend to be, right, machine learning problems where we give features to the model but without the label, right? Here we are trying to make a different type of prediction. And a good example of such will be clustering, or something you call association in machine learning as well. So association is, think about the association basket. Someone was able to just have a data set of what people just typically buy when they go to a supermarket. That's all they had. So it's just data. It's all features on what people typically buy when they go to the supermarket. But by working with association, you're able to find that whenever someone bought milk, they usually bought bread as well. So very, very key thing there. Or one interesting algorithm that was able to detect a pregnancy in a teenager very, very early on is, I think Walmart had such an algorithm that could easily look at what you bought when you go to a store. I don't know if it's Walmart or Target, And there was one time someone just bought a couple of things when they went to the supermarket. They just serve data. There was no label. There's no labeling here. It's just data of what you buy when they go to the supermarket. And then all of a sudden, there was this father and I think 16-year-old daughter, and they came to complain to Walmart. They're saying, you guys are sending a lot of advertisement on, let's say, pregnancy items, right, to a 16-year-old. And that was quite sad because it's a 16-year-old. You don't expect that. You're the father, you're concerned. And he wanted to just sue Walmart or Target for that thing in particular. But then, when they actually went for a pregnancy test, apparently she was pregnant, which is quite interesting. Essentially, an association basket was able to learn patterns of how someone bought different things in a supermarket and was able to detect pregnancy before a pregnancy test in the first place. Apparently, the machine algorithm was able to understand what are some things that people usually buy when they're pregnant, right? Probably you have cravings of things you want to eat as well, and they're able to predict that quite early. So that's like an unsupervised learning problem. Yes, we just serve data over there, and the data was able to associate with each other, and most of the time, they associated pregnancy with, let's say, the basket she was buying. Another good example is clustering. YouTube is a good example of clustering, whereby we just have data on videos, right? And what we can do here, we don't have a particular label for these videos, but using the clustering algorithms, we can be able to cluster videos together so that if you watch a video in a particular cluster, we don't know how to define these clusters in the first place, but we are very, very confident that because machine learning algorithm has clustered this together, if you watch a video in one cluster, then you're likely to watch another video within that cluster as well. So these are challenges that we don't have the label, right? So it's not like we have a solution there, but we're just trying to identify patterns that allow us to make a particular prediction, right? Or key assumption. And we'll see supermarkets use that to sell goods to you, or a tool such as YouTube using that to recommend videos to you as well. Final aspect of machine learning will be time series analysis. We are working a lot with time series data, right? Most of you would think that a regression problem would easily solve this. Yes, you could think of it like that. But time series data usually have patterns, right? The seasonality in time series. There's just a lot that's a bit different from your typical regression when it comes on time series analysis, that you want to understand the statistics behind it and how to work through time series analysis as a data scientist as well. So financial data usually comes in time series format. Think about sales data as well, comes in time series format, right? So when I talk about financial data, I'm talking about stock markets, things of that sort. What else comes in time series format? Weather, right? If we were to predict the weather as well, that's definitely a time series problem. So there's a lot of things that work in a time series format and these are very, very common types of data sets as well. So learning time series analysis is very, very key. So given what I've mentioned here, I will just recommend the Python libraries for this. So for supervised learning, go use Scikit learn, right? That's the library to learn. For unsupervised learning, we're still using Scikit learn. Yeah, something I've failed to mention here is we have things such as feature engineering. This is like dimensionality reduction. For data as well, it's also an unsupervised learning problem. Cool, dimensionality reduction. So let me just call that, we usually call that feature engineering as well. So that can also be done with sklearn as well. There's also some unsupervised learning tasks or other tasks that you might tend to use SciPy for. So I think outlier detection might be one of them. I'm not so sure. I need to go check my notes again. But SciPy is also a very, very key library to learn. I would recommend just focus your time on Scikit learn. The rest will come in. As you're learning after that we have time series analysis. sklearn will not help you so much with this. So if you're still on Python, we have a library called stats model for that. The skills you want to learn as you're learning machine learning is model evaluation. Very, very key thing. How do we evaluate our model? Here we're looking at metrics, right? We're also looking at how we tune the hyperparameters. Each and every single model takes in certain parameters, and we want to tune them to see what will be the most accurate parameters. That's what you're looking for in model evaluation as well. Model deployment is something I'll talk about later on. Let's say also as you're learning machine learning, it's always nice to learn this library so that you can do data preparation with them. So there's certain skills such as normalization. So what is normalization in the first place? It's a data preparation technique as well, available on Scikit Learn. There's a lot of different concepts over here. Outlier detection, some of the things I'm talking about there that you just want to learn through, whether you're using SciPy or sklearn. I think R might have some solutions for that as well. So this ones, I'll just put them in as blue because they're not a machine learning problem, but things we do within our machine learning pipeline. Okay, any question for me so far? No questions? Cool. Now, I do understand that whatever I'm sending down to you is a bit of a mouthful. I definitely understand that. I shouldn't be talking too much about them, but I think what you need to take off at the end of this call is you just want to know uh, at that point when I'm learning machine learning, what are the things I need to learn to call to say I'm versed with machine learning? Or that time I'm learning Python data analysis, regardless of what course you take, what are some of the things I need to have learned to be able to do that? So that's why I'm just listing them here. That's why I'm getting a bit detailed, even if they might not make so much sense. The moment you start learning machine learning, all courses will start with supervised learning. Then you can remember that you are supposed to learn about the regression models and classification models. Then when you go to unsupervised learning, you can remember you're supposed to learn about clustering and dimensionality reduction, which also we can call principal component analysis. At least when you're learning math, you learn it as PCA as well. Oh, and then most courses will tend to ignore time series. That's why I'm listing this so that you know it's a very, very essential skill over there. And model evaluation, data preparation, very, very key skills. In fact, you always need to prepare data before you serve it to a machine learning model. So understanding the different techniques for data preparation is a core skill for any data scientist or machine learning engineers. Okay. If you want to get into AI, that is the deep learning segments, you can go ahead and learn more tailored libraries for neural networks over here. Learn about neural networks. What are they? Some of the library options we have for deep learning are TensorFlow, PyTorch, Keras, Theano. There's a lot over here. I will say I do not recommend you learning deep learning. It's useless if you do not have a postgraduate degree in the space. Most companies will only let people with postgraduate degrees work on that. So if you don't have a postgraduate degree in deep learning, I think you're just better off learning machine learning and being a very, very good data scientist than pushing yourself into neural networks, because no one will let you handle that unless you're coming from a high mathematical statistical background, or let's say deep learning background from with a master's degree or a PhD. Those are the people who tend to work more on deep learning, because for them, they won't just be working with libraries. At times they even just design algorithms from scratch as well. So think about it. It's a very, very key thing. You can learn, definitely learn TensorFlow, right? You can use TensorFlow for machine learning still, but don't spend so much time on deep learning. Most of the problems you'll encounter as a data scientist can be solved with machine learning. But if you feel like it interests you to learn about neural networks, definitely go the extra notch, and you can start doing things such as computer vision, driverless cars. Those are some of the big challenges we have over there, right? Think about audio, right? Can you handle audio data? Can you make predictions with that? Those are the hard data sets to do. But learning deep learning allows you to make more accurate predictions. So time series analysis, yeah, you can make accurate predictions, but you can even make more accurate predictions with a neural network, right? You can also do a regression with a neural network. At times it's an overkill. So if you ever encounter a problem that needs extra accuracy, or you cannot get the accuracy metrics you want to hit with machine learning, then deep learning is an option for you. But I would say most of the people working in deep learning would come with a postgraduate degree into the industry. Most companies have that particular bias. Okay, now this is something I definitely recommend any data scientist learning because it's essential. But I'll recommend it more for people who don't want to work more in machine learning, but they want to work more in how you handle big data and you channel it out to the models, how you do the cleaning and how you source the data in the first place. These are the people who are handling the big data. Yeah. So it's not just being a database administrator, is how you handle this big data pipeline in the first place. Some skills to learn here: Apache Hadoop, Apache Spark, Apache Kafka. In fact, I would say this is the more on-demand job role in the market at the moment. Every company is trying to use machine learning in one way or another, but there's very few people who are versed in data engineering to be able to craft up the data pipeline so that their data scientists or machine learning engineers can use that particular data. Upskilling into big data engineering sets you aside. You can earn more with this than data science as well, because it's on demand. Not very many people are data engineers. Yet all these companies that use machine learning concepts definitely need a data engineer as part of their stack. Okay, so I've just talked about some of the concepts here. There's more to learn here. Kindly check out the resources I'll send for more on data engineering. But you could specialize in data engineering, or you could go ahead and specialize in deep learning. For those of you who just want to do extra AI and machine learning, these are people who want to go back straight to the databases and data cleaning, or just, yeah, handling big sorts of data, big batches of data efficiently. Cool. Now, our call is coming to an end, but not before I talk about some things here. Uh, the biggest gap we see with a lot of data scientists is most of them cannot deploy their models. What I mean by deploying your models is I have done this, right? I've created a housing price predictor using a regression algorithm. I've optimized it. I have a 95% accuracy on this data set. Now, the next step for me is there a way I can deploy this model online so that anyone can go to this particular website, and when they put in the features of their house, I can output what is the predicted price of that house, like how they should price that house in the first place. So yes, I have this, right? Everything is well done, but can I go the extra layer by having it online so that people can make predictions using my model just by filling in some of the features you have over there? Very, very essential skill, because we're not just building these models for ourselves, right? Because at times companies are building this model so that they can be fed into other tools that they use, or within the company as well, or for their users. It's quite essential that data scientists also understand model deployment. It also allows you to start thinking about efficiency of your model, particularly when you have to deploy to an end user. So a good example is Netflix is using a model to recommend movies to you, right? Whenever you want to watch a film on Netflix, there's a model that has been deployed that is able to tailor up the listing, yeah, based on the likelihood that you're going to watch it. That's good. So someone created the model, but when they're building the model, they realize that people who are watching movies on Netflix care more about the speed of this recommendation. It shouldn't take so long to load. So would they go ahead and use a very, very advanced neural network because it's very, very accurate, or will they go ahead and look for a simpler model that still makes a less accurate but still very, very good, right, prediction of what movie you're likely to watch and deploy it there? And your data scientist will just worry about accuracy. But the moment you start putting deployment into the mind and into your picture, all of a sudden you can start compromising accuracy for the sake of efficiency here. And these are some of the skills we're seeing data scientists should really, really start grasping. By knowing model deployment, you start to see what are some bulky things that you cannot have on a typical website or mobile application if you have to deploy it in the first place. Second thing is cloud computing here. It's very hard to find a tech career right now that does not rely on cloud computing. This is how we host almost all our web application. This is how we host all our models as well. If you're creating an automated data pipeline, most of the time everything will be hosted on a cloud platform. A good example will be Amazon Web Services, the market leader there. We have Microsoft Azure coming in close there. Google Cloud Platform, still a new entrant when you think about the market at large, but I think it has the highest pay uh, pay rate over here because there's very few engineers who are well familiar with Google Cloud in the same way as we see with AWS. So whether you're a data engineer or a machine learning engineer who knows model deployment, right? Most data engineers will be well versed with model deployment because they'll be working with that particular pipeline. Actually, not model deployment. They'll be well versed with cloud. You need to be well versed with cloud because you're working with that data pipeline and your data is on the cloud anyway in a database, or you're working with machine learning tools that are already available on cloud. So very, very key skill for data engineers or machine learning engineers as well. Cool. For model deployment, you can use the Flask library. When you're using Python, it's a good example. I think we have a library called Streamlit as well. If you just want to deploy a small model, right? This is a very, very quick way to deploy a model. This is quick. It's not for your fancy things. But if you want to deploy models into a typical web application, then you want to learn how you can deploy your model with Flask or Django. But over time, it's nice. Once you understand how to deploy a model with Flask, at least even if your company is using a different stack, you guys will already know what sort of optimizations you need to make so that your model is available to the software developers with whatever other framework they're using for the web development. But I've suggested this because these ones are the ones that are based on Python. These are the Python backend development frameworks. Streamlit is just a quick one for data scientists. So I've built my house price regression algorithm. Can I just deploy it very, very fast so that it becomes a form that can link you up to my model and you can make a prediction very, very fast? Yes, quick way to do it, but most web apps will tend to work with Flask or Django, at least with Python. Cloud computing, and then this might be more relevant to data engineers. Make sure you learn containers as well. People are working with a serverless architecture. We are serving our deployments in containers as well. Learning Docker or Kubernetes. These are very, very key skills for data scientists and data engineers in the world today. Cool. Now, quite a mouthful. I don't expect you to remember everything that I've talked about, but I expect you to use this guide whenever you're learning by yourself. And what I'm going to do after this workshop is share these slides, share the video as well once I upload it to YouTube, and even more importantly, share resources on where you can get started tomorrow if you want to chart your career into data science. I will email the slides to you guys. Don't worry about that. Okay. Now, to close off the call, I think we're overboard with about 15 minutes. Let me see if you guys have any questions for me based on what I've talked about. Okay, thank you very much, guys. I hope it's been helpful. When I started my own data science career, I didn't have a guide that was this detailed so that I know what to cover. So I ended up taking way longer than I needed to learn some of the core skills that I have today. But whenever you have such a guide, it makes it very, very easy for you to learn faster and for you to know where to focus your time on when you're learning. And I hope this slides, this video recording, and the resource links that I'll be sending will be instrumental to you guys upskilling into data, whether or not you're into biochemistry, whether or not you're into human resource, and you just want to see what data science can do for you in that, or if you just want to chart a new career in the field as well. Thank you very much, guys, for attending. Have a nice time, nice night wherever you are, or nice day. I know we are all from very, very different time zones.